says, and this is what we call indirect measurement, basically measuring the height of something without physically climbing the tower to drop a tape measure. Does that make sense? Usually indirect measurement is incorporating the use of easier or more tangible measurements, things that you can gain a little bit easier, along with some physical properties, some geometric, trigonometric properties to allow you to determine the exact height of something which you don't have to measure. Okay, so this one is using similar triangles. This is a 4-foot vertical post. So 4-foot vertical post. So let me draw my post here. So that's a post. It has a shadow that is 14 inches. Okay, so that is a big issue here with a lot of these questions. Something that's pretty tall. Okay, maybe I don't know, like a 5th grader casting a 14-inch, a pretty small shadow, right? What's that tell you where the sun is? It's pretty close to being overhead, isn't it? Something to think about. It's not necessary for this question, but if you got a pretty small shadow, you should have then the sun pretty close to being straight above you. Not a huge deal though, but that's the situation going on there. Then we've got a cell phone tower. Don't know how tall it is, but it has a 119-foot shadow. We want to try to figure out how tall it is. Okay. The idea here that allows us to create the correct proportion is the fact that we're going to make the assumption that the post and the cell phone tower are perpendicular to the ground. Okay. And we have an understanding of physics that says that essentially from the tip of this shadow, looking straight into the core of the sun, that we call it an angle of elevation. Okay, if we have at the same exact time of day 2 shadows and we're looking straight into the sun at the tip of those shadows, those 2 angles right there, those 2 blue angles would be congruent. Okay, so what we've got going on here is angle. Okay, that's the similarity statement that we're allowed to say. Now, we don't have, you could put labels on here and everything, A, B, C on this one, and maybe D, E, F on this one. That's not, I don't think, necessary here. In order to create a proportion, I hope you guys understand that I should compare a vertical distance, a distance or length of the object compared to the length of the object. Does that make sense? Or the height of an object. So height of post compares to height of tower. Shadow of post compares to shadow of tower, right? Does that kind of make sense? Shadow to shadow, height to height. So I'm going to say 14 inches compares to 119 feet. And write that equal to then 4 feet compared to X. Does that make sense to everybody? Again, just make sure my numerators have a link. And my link for my numerators is that they both came from the same shape, right? The link for my denominators is that they came from the same shape. If I were to cross multiply and do all that kind of stuff here, I would be 100% wrong. Why? Okay, because that unit of inches. Okay. Now you've got 2 options. You can change everything into inches, and a lot of people like doing that. Change everything into inches, get an answer. And I see people do this previously on this assignment. Type it in as have the right answer, the right height, but your answer be in inches. They type it in and it gives it to them wrong, right? So you can change everything in inches, do all your work, because that might be a little bit easier. And when you get an answer, you think I would divide that by 12 to get back into feet, right? So that's something you can do. In order to kind of alleviate that, what I'm going to do is say that 14 inches is the same thing as 14/12 feet. Right? That makes sense? Okay. Now, if you want to, so I don't think it's too bad. Shouldn't be too bad. 14 divided by 12 as a decimal. If you want to write it that way, maybe round to 2 decimal places or something like that, or 3 decimal places, that would be okay. I'm just going to leave this 14/12. When I cross multiply, okay, 14/12 times x is just 14/12 x. And then 119 times 4, well, say again? 476. Okay. Now what would I multiply both sides by to get x by itself? Careful. 12 over 14. Multiply by that reciprocal, right? So 12 over 14 here. Those who cancel to 1. Multiply over here by 12 over 14. So what I have to do then, 476 times 12. Divide that then by 14. And 408 feet. Is that all right? Okay. So 408 feet would be that answer. Now, you also, like I said, you have the ability, if you wanted to change everything into inches. Okay. So if I would have changed everything into inches, it would have been left as 14 inches. Now, 119 needs to go to that number. 1428. 4 feet needs to go to, what, 48 inches? And then x. So I get now 14x is equal to 48 times 1428. Let's see what that is. 48 times 1428. So I'd have 14x equal that number there, right? Well, what I need to do with that number to solve for x? Divide by 14, right? And now I have that number. But that number is in what unit? Inches. My answer needs to be in feet, so do what with that? Divide by 12. Okay? So dividing by 14 here is essentially the same as the division of 14 that we had there. And now multiplying it by 12 is the product that we get right there when we multiply by that 12. And when I hit enter, maybe, hit enter. Oh, what did I do? Oh, I needed, I'm sorry. I needed to divide by 12. So 48, 96. My explanation there might have been backwards. 49 divided by 12. Gives you that 408. Okay? So either approach is fine. Either do everything in inches and then convert it back to feet, or change everything to feet and go through and you'll end up with your answer immediately. Okay? Always pay attention. You're going to see some questions in your homework tonight that force you to pay attention to that. I'm going to give you test questions that force you to pay attention to that. The reason for that is the end of course exam on purpose does that. They try to get you to miss questions just because of units. Okay? The ACT does the same thing. The ACT will actually put, what was it, 68, no, I'm sorry, it'll put the 4896. It'll put that as option A. Because some people will do the question, get 4896. Oh, that matches one of my answers, I must have done everything right. Option B will be 408, and that should be the one you should choose. Okay? So just be careful of those types of things. And I'm going to try to train you based on just being exposed to them over and over and over again to pay attention to that. All right, so question 8 then was one that was probably really enjoyable to do, right? All right, and I'm going to actually, I think I did this version of it in the last class. So if you had those numbers, you can go through that video from the last class and do it. Or look at it. I'm going to use these numbers just so I can get different situations kind of recorded. Because ultimately it comes down to factoring, and I want to be able to see and get exposed to as many different forms of factoring and examples that we can that are a little bit different. All right, so these two triangles, they say they're similar. All right, now we talked about similarity being like angle, and side, and using those two facts to help us decide which things should be compared to another. In this situation with these triangles, we don't have enough to say, I'm looking at, maybe this angle here is congruent to that one. They don't give me enough stuff to actually compare which angles are congruent to one another. Does that make sense? I don't know if that angle there is congruent to that one or congruent to that one. So that would make things hard to compare if they didn't give us the hypotenuse. So let's say they put this 45 over here and put this x plus 8 over here. Okay? Without any other information. All they did is said that these are similar. I don't know now if that 45 should compare to the 24 side or if the 45 should compare to the x plus 8 side. Does that make sense? Okay? Because I don't know which one of these is bigger. So I don't know which one of these is bigger, right? But when I look at these values, which one of those has to be bigger? 45, right? Because it's across from the bigger angle, right? The hypotenuse is always the biggest side. So when I either shrink or enlarge this triangle to get one that is similar to it, shouldn't the hypotenuse still be the largest side for this figure here? So that's the argument that allows us to say 45 over x plus 8. Okay, those are the parts that we compare, hypotenuse to hypotenuse. Okay, so if that's the case, then the only things I'm left with are 2x minus 8, and that should compare to 24. Does it ever stop raining? So that's a tough question. Or we're talking about like globally, I would say no. If we look at that, that is a proportion that we all have the capacity to solve. All right. Let's just go through and maybe write the varying formats that some of us might have gone through as we cross multiply. Okay. When I cross multiply my means, x times 2x gives me what? 2x squared. X times negative 8 gives me negative 8x, right? 8 times 2x gives me 16x. So negative 8x plus 16x should give me positive 8x, right? So that positive 8x came from my O and I from the foiling process. And then 8 times 8, 64, right? And this would be negative. And then 45 times 24, 45 times 24 ends up being 1,080. Okay. Then what I'm going to do is take that 1,080, because I have that x squared, so I know I need a factor. So I'm going to get this 1,080 to the other side, and I get negative 1144 here. Okay. So that is one option. I think that's maybe the most kind of direct, lack of fault maybe option. Nothing wrong with it, but let's kind of look at this ratio over here and see if there's another thing we can do. Look at that ratio. Is there a GCF in the top? Take that 2 out, right? Is there the same GCF in the bottom? Okay, so I can do that, right? So now, if I cross multiply the x minus 4 and the x plus 8, because those are now my my means, right? I would get, I'm going to write this down here, x squared, 8 times x, and then x times negative 4, so it would give me 4x. Okay, and now 8 times negative 4 would give me negative 32, right? Equals then 12 times 45 is going to be, is that 540? Okay. And then I'm going to get x squared plus 4x minus 572 is equal to 0. That is a perfectly fine approach. You factor that 2 out, right? Now, for those of you that would have done what we've got written here in black, there's nothing wrong with that. And I know a lot of you are going to do it. And to be honest with you, when I'm doing these, that's probably the route I'm going to do. Okay? Because this factoring of 2 isn't always going to happen. So I a lot of times just ignore it and just go straight to this. But now, what do you recognize will divide each one of those things? Can 2 divide each one of those? You get x squared plus 4x minus 572. that look familiar? That thing right there and that thing right there are the same, right? But I still got this 2 out here. All right, and I need you to understand this because of the algebra that you're going to go through in the coming years. If you have an equation, you can divide both sides by that GCF of 2. So I can divide this side by 2, and I can divide that side by 2, right? Okay? Cancel. Leaves me x squared plus 4x minus 572. What's 0 divided by 2? 0. And that gets me exactly what I had over here, right? So the factoring that I did here of this 2 is identical to the factoring that we did up here with that 2. Is that all right? I just took out different places. Somebody in the last class said, yeah, I just got rid of that 2. You need to know why you got rid of that 2. Because there will be situations beyond this where we'll have something like 2x squared plus 8x minus 1144. Factor a 2 out of everything. And now I can't get rid of that 2 because now I just have an expression, right? And when I want to rewrite expressions, I can't change what they do. I can't change when I put an x value in up here. Let's say x was 0 up here. I would get negative 1,144, right? I got rid of that 2, and I say that wasn't there. I just started it, got rid of it, factored out, plug in x of 0 here, you get negative 572, right? Well, if these two things are supposed to be just alternate versions of one another, I should be able to plug in the same x value with the same output value. So that's why, in this case, it's an expression that I'm simplifying, that 2 up front needs to stay. Does that make sense? So it can go away when it's an equation. You can divide both sides by it. But when it's an expression, you need to make sure it maintains and stays out there. Okay? This is something that I have a lot of people through my college algebra, my trigonometry classes, my calculus is a huge deal, to know when the GCF can disappear and to know when the GCF stays. See it? So now we factor this thing, right? Okay, so we're looking for 2 numbers that multiply together, give me 572, and add up to give me 4, right? Now 572 is negative, correct? So my 2 factors have to be what kind of numbers compared to one another? Can they both be positive? No, because a positive times a positive should give me a positive, right? Can they both be negative? No, because a negative times a negative should still give me a positive 572, right? So one of them has to be positive, one of them has to be negative, right? Agree with that? All right. Now, this is kind of a trick that you can use that's very useful. Okay? I'm going to take the 572, and there's other things you can do. I'll show you another one tomorrow if we have time. I'm going to take the 572 because this number, the 2 numbers that multiply together to give me 572, are 4 units. We're talking about absolute value, maybe. They're 4 units apart from one another. Does that make sense? If I just look at their both being positive or both being negative, they're 4 units away from one another. So let's do this. Let's take the 572. What we want to do is we want to find kind of the midpoint, the mid value, okay, for this process. And we really do that by taking square roots. So I'll take the square root of 572. All right, and you'll learn later on why I take square root, same thing as raising to the 1/2 power. So it's just easier for me to calculate that. So I know that my factors right now are close to 23. Does that make sense? Okay. So the way I go about this is I take my 572 divided by 23. And I'm hoping for an integer back. Okay. No decimals. So I don't get that. So then I take the 572, I take the exact same thing, and I either increase or decrease that 23 by 1. And it doesn't matter. You go up or go down. So I'm going to make it 24. And that doesn't get me what I want. So then I redo it, and I go 25. Okay. Hopefully you knew 25 wasn't going to work because that one ended in a 2, right? Okay. So then I try 26. And in that situation, I've got an integer back, right? What do you notice about the 26 and the 22 How far apart are they from one another? 4 units apart. Okay, so that 4 units apart is that 4 there. Okay, now one of them has to be positive, one has to be negative, right? So I'm going to write x. Which one has to be positive? 26, right? And the 22 has to be negative. All right, so it gives me x to equal negative 26 or x to be 22, right? Now the question said, write both answers, or write your answers with a comma if needed. Do I need a comma here? I have 2 answers, right? Or do I? I can't put negative 26 in there, right? Because that gives me negative 18 back for a distance. So negative 26 is the extraneous solution. It doesn't work. 22 is the only one that we want to put in there. Is that okay? Okay. Now, that question was on the quiz. I don't know if I said this earlier. It was on the quiz Friday, right? I just wanted to see what you had learned so far. All right. I'm actually going to give that as a bonus question on that quiz. So if you got it right, great. If not, it's not going to hurt you. Okay. Are there other ways I could have approached that? Quadratic formula would work, right? Now here's the thing that and hopefully you guys learn about mathematics, is that because these 2 numbers were whole numbers, they're integers, okay? No decimal parts, no fractions, anything like that. When I use the quadratic formula, it tells me that the b squared minus 4ac part, that will turn into a perfect square, okay? And that's just kind of after doing enough of these and learning the ins and outs of the algebra, those are things that you can kind of make links between. All right. I'm not going to go through that because I think we'll run out of time with some of the other stuff I want to cover. But that's that approach. Now, hopefully, you guys see why we've been talking about how to